Good morning. My name is Marco Fina. I'm from Sysman Progetti Servizi, the technology provider for the use case. So what we have done, what we are going to do in the near future, our task. Everything started from Blueleaf. As Vincenzo said, Blueleaf is already in the market. Is a decision support system for water and pest management. And within the project, we are going to improve it for organic table grapes and pest management. We will use MFC tags to identify crops and plots, and we are developing and now we are testing IoT sensor that use Sigfox network and soon LoRa network too. What is Blueleaf? Blueleaf is an integrated DSS solution. Integrated means that it's a hardware, weather station, sensor, software developed by us, and agronomic support to offer support for water management and pest management. Blueleaf works in a cross-platform environment. You can use it from web, you can use it from mobile, both Android and iOS devices. NFC tags. NFC tags, we are using them to identify crops and plots, as I say. This is an example of tag. Why tag and not NFC tag and non-GPS? Because it's faster than GPS. You know that sometimes it's better to have a mobile internet connection to have a more defined measurement. So that's why we're using NFC tag. And we also developed an app, a mobile app that allows the farmer to scan the device and access a platform where you can insert information about crop or, I don't know, pest, daily activity, and whatever the farmer wants to add by text message or vocal message. I can show you the app if someone is interested later. The DSS, as you know, the DSS needs data to work. Every DSS, not only our DSS. Standard application, standard weather station works with the sensor connected via cables, but sometimes it's really difficult to install them because you can have routine problems, installation time, and so on. So we are working, and we will work with the IoT sensor, as I say, developed by us, that works with our virtual data logger. So we don't need an hardware data logger in the field anymore, because everything is runs on our cloud infrastructure. And data are sent through the Sigfox network. This is our first sensor we developed using the Sigfox. Is a thermohygrometer, and actually it's into production. So we are getting data from this sensor since from last May. This is the standard approach of standard weather station and sensor. We have two weather station, sensor connected via cables near the weather station. Our approach for IoT sensor, as I say, we don't need an hardware data logger, so easy implementation. Every sensor sends data directly to the cloud, and they work with battery. And probably one of the most important features is that you can manage your infrastructure directly to a web application. This is the approach with IoT, so you can have multiple sensors in the field. I forgot to say, it's a real case application. It's our use case application. So what we have done, we installed a standard registration sensor and electromechanical valve actuator, where the farmers can schedule and activate and deactivate the valve through mobile phone. What we have done last year, we installed our IoT sensor. We had some challenges. The first one, battery life, as you can imagine. Communication technology and sensor accuracy. What I mean? The results. Battery life. We installed the sensor last May, and we are not having any problem with battery. We never changed battery, so our goal is to have 1 year, 1.5 years. I don't know if we can get 2 years of battery life. Anyway, till today, we don't have any problem with the battery. Communication technology. Sigfox is work without problem for us. We have 4 sensors at the moment installed. We are getting data, no problem. Accuracy. We had one problem with one sensor, the soil moisture sensor, but it's not really a big problem because we are changing it, and probably is a good problem for the project. As I say, battery life. We are expecting to get 2 years of battery life, but now we are almost at 1 year, so we are confident that we can reach the goal of 2 years lifetime for some sensors. I don't know if we can reach 2 years for every sensor. Communication technology, as I said, we have no problem with Sigfox, but in the event that you don't have any coverage of Sigfox network in your area, we are working to develop a LoRa solution too, a modular LoRa solution. I mean that with the same sensor, you have to swap your RF module with LoRa or Sigfox, and you can use the same device, the same electronic. In the real use case, I have to say that we have no mobile phone coverage, but we have Sigfox coverage. So it's a good example of communication technology, in my opinion. Accuracy, as I said, we had a problem with one sensor. I forgot to say that we are testing a really low-cost sensor in order to compare the results, the measure with the standard sensor. We are having a problem with the one sensor, soil moisture, as I said. We are working to swap it with another, always low-cost sensor. A good example of interoperability and synergy within the project is with the use case 1.3 with Donau Soia. We are working with them to develop a DSS for them, starting from our DSS. We are working on it. We released the first beta version, and it's a good example of synergy and interoperability within the project. Next steps for us. Continue to work on low-cost sensors. But the main goal for us, as Vincenzo said, is to out-estimate the KC coefficient directly in the field. And I think we will be able to install the PAR sensor soon. Soon, I mean before the end of this month, and start to work on KC coefficient 2. A big goal for us is the real prototype of our sensor. This is the first print of the case. Actually, is a 3D print to test everything: the size for PCB, the size for battery, and everything. It's made of plastic, but is not ABS at the moment. We will want to print it with ABS. And the next steps are, we have to move into production environment. What I mean that before the end of the second quarter, we will have data acquired through IoT sensor as an input of our DSS solution. So we can start to elaborate, process data from IoT sensor. Pilot upscaling.